Hi all, welcome to TutySpot. In this video, let's discuss about context-free grammar, CFG. Context-free grammars are a fundamental concept in compiler design, primarily used during syntax analysis. That means parsing phase. A CFG is a formal system used to describe a class of languages known as context-free languages. That means they provide a formal and precise way to describe the syntactic structure of programming languages. These class of languages are known as context-free languages. CFG is formally defined by four tuples. G is equal to V, T, P, S, where G means the grammar, V means set of variables or non-terminals, T means the set of terminals, P means set of productions, and S is the start symbol. V is a collection of variables or non-terminals. That means uppercase letters like capital A, capital B, capital C and so on, or lowercase italic names like expression, statement, like that many more. These non-terminals mostly used for substitution purpose like A produces small x capital Y and B produces small u capital V. Like this, non-terminals are used for substitutions. And T is the set of terminals or symbols or lowercase letters like small a, small b, small c and so on, and symbols like operators, plus, minus, into and many more, and punctuation symbols like comma, parenthesis and many more, and digits from 0 to 9 and boldface letters. Basically, these terminals are used to generate the strings. And P is the set of production rules. Production is of the form where LHS is always equal to RHS or head is equal to body, where head contains only one non-terminal like variable and body contains a collection of terminals and non-terminals. Suppose consider A belongs to alpha. Here A is the variable and alpha is the combination of variable, that means non-terminals, and terminals with 0 or more occurrences. So in RHS we have the value of alpha as epsilon or a combination of terminals and non-terminals. Next, S is the start symbol. It is the head of the production stated first in the grammar. Suppose consider a production, for example, A produces small x capital Y and B produces small u capital V. So here A will be the start symbol. Let's see the CFG with an example. Consider the grammar E produces E plus E or E into E or within the parenthesis E or ID to obtain the string ID plus ID into ID. So here V, that means non-terminal, is E, and for T the set of terminals we have symbols like plus, into, parenthesis and ID. And for P the set of productions we have E produces E plus E and E produces E into E and E produces within the parenthesis E and E produces ID. We have 4 productions and the start symbol is E. So the string we have to obtain is ID plus ID into ID. To produce the string, let's consider it from left to right. First consider plus. To produce plus, first take this production E produces E plus E. We have the production E produces ID. So replace this E with ID. So we got ID and plus. So the rest we have to produce is ID into ID. To produce this ID into ID, we have the production E produces E into E. Replace this E with E into E. So the required operators are plus and into. Up to here we obtained these required operators. So now we have to replace these E's with ID. Coming from left to right, replace this E with ID. As we have the production E produces ID, replace this E with ID. And then replace this E with ID. Like this, our required string is obtained. ID plus ID into ID. This is the required string. Collection of such these strings form context-free language, and this is all about context-free grammar. Thank you.